Assalamualaikum warahmatullahi wabarakatuh. Welcome to our MAT272 Introduction to Mechanics video presentation. Our team consists of two members. I am Muhammad Alif AIMAN bin ZANAINI.
And I, Muhammad HAKIM bin Muhammad NASSIR.
We are from group D1CDCS1434B. Our objective for this video is to understand the fundamental of physics, confirming the principles of free fall as described by mechanics and the equation of uniformly accelerated motion.
Second objective is to solve problem related to free fall motion, such as determining the time taken by an object to reach ground with certain velocity and height and more.
A free-falling body motion is defined as the vertical motion of a body at constant acceleration under gravitational field without air resistance. Constant acceleration G is also known as acceleration due to gravity or free fall acceleration. In other words, free fall body motion refers to the movement of an object under the influence of gravitational force only, without any other forces acting on it, such as air resistance. If an object is thrown upwards, it initially moves against the direction of gravity. As the object moves upwards, it slows down due to gravity's pulls, which acts downward. This deceleration is also at a rate of g. The object reaches its maximum height when its velocity becomes zero momentarily before it starts to fall back down. In other words, if an object is moving upward, the speed will reduce. When we consider the downward direction as positive, it simplifies the equation for free fall because gravity accelerates objects in this direction. Velocity in the downward direction is positive. Speed is always a positive quantity indicating the magnitude of motion. If the direction of the object is downward, the speed will increase. The equations of free falling bodies can be summarized as below. First, V equal to U minus GT. Next, S equal to 1/2 U plus Vt. S also equal to Ut minus 1/2 GT squared. And lastly, V squared equal to U squared minus 2GS, where V is the final velocity, U is the initial velocity, G is acceleration due to gravity, T is for time, and S for displacement. In a free fall situation, all objects, regardless of their mass, experience the same acceleration due to gravity, which is approximately 9.81 meter per second on Earth.
Example of free fall.
For example 1, a ball is thrown vertically upward from the edge of a 75-meter building and falls to the ground 5 seconds after leaving the thrower's hand. The thrower's hand is 3 meters above the roof of the building. So here the solution for the example 1. As you can see here, we got the information about the height of building. We got the time falls to the ground, which is 5 seconds, and also we got the thrower's hand, which is the curve, head of the curve is 3 meter, add on 3 meters. So how to solve it? I use the formula S equal to Ut minus 1/2 GT squared, and the S is equal to -78. Where I got it from the head of the building, which is 75 meter, and I add with the height of the curve, which is 3 meter, so the total is 78 meter. Why it is negative? Because the curve is down to the ground, so that negative 78. Negative 78 equal u, which is what we want to find, initial velocity, and times 5, which is times minus 1/2 g. G is gravity, and t is time, which is 5 seconds times square. And then we got it, the initial velocity, which is 8.925 meter per second. So here the second solution for the question example 1. Question 2, time taken to reach the maximum height. So here we want to find the time to reach the maximum height. So you can see here V, we got the 0 and U 8.925 meter per second. So based on the information I have, I think it's suitable to use V equal to U minus GT, which is T is what we want to find. And then after we key in the information, we got the time equal to 0.9 seconds. Example 2. A stone is thrown from the top of the building with an initial velocity of 50 meters square upwards. The building is 40 meter high and the stone just misses the edge of the roof on its way down. So the first question of the example 2 is calculate the maximum height of the stone from the top of the building. So here we got the initial velocity, which is 50 meters square, and of course the final velocity is equal to 0. So I use formula V square equal to U square minus 2GS, and then after keying the information, we got the answer, which is S equal to 11.4678. Second question, the total time taken for the stone to reach the ground from the top of the building from A to C vertical displacement, which is S equal to 0. I use the formula S equal to UT minus 1/2 GT square. After keying in all information, we got the time, which is 3.05 seconds.
Example 3. A construction worker accidentally drops a wrench from a height of 50 meters from a stationary construction platform. Assume that air resistance doesn't exist. For this example, what is the initial velocity of the wrench as it starts to fall? And what is the acceleration of the wrench during its falls? Since the wrench is dropped from rest, its initial velocity U equal to 0 meter per second and the acceleration A equal to negative 9.8 meter per second. Next, how long does it take for the wrench to reach the ground? Using the equation S equal to UT plus 1/2 AT squared, where S equal to 50, U equal to 0, and A equal to 9.81, we got T equal to 3.19 seconds. So we can conclude that the wrench took 3.9 seconds to reach the ground. Lastly, what is the final velocity of the wrench before it hits the ground? Using the equation V equal to U plus AT, where U equal to 0, A equal to negative 9.81, and T equal to 3.19 from the answer of previous question. We got V, the final velocity, equal to negative 31.28 meter per second. So we can conclude that the final velocity of the wrench before it hits the ground is negative 31.28 meter per square.
Conclusion. In conclusion, free fall body motion can be defined as vertical motion, and by focusing on the effect of gravity separately, free fall simplifies the analysis of motion, allowing accurate prediction about the behavior of object over time. Additionally, free fall provides a clear introduction to key principles such as acceleration, velocity, and the relationship between force and motion.
That's all from us. Thank you for watching.